Welcome to Quantum Technologies, and I hope you look forward to learning um, a lot of interesting information that I have been putting together over the last few years, which has culminated in this quantum biology online course. Um, I'd love your feedback and happy to interact in order to improve the course, make it easier for people to understand, and so you can get the most out of this. You can as well. Okay, cheers. Hope you enjoy.
And here we are, the granddaddy of all quantum weirdness, the infamous double slit experiment. To understand this experiment, we first need to see how particles, or little balls of matter, act. If we randomly shoot a small object, say a marble, at the screen, we see a pattern on the back wall where they went through the slit and hit. Now, if we add a second slit, we would expect to see a second band duplicated to the right. Now, let's look at waves. The waves hit the slit and radiate out, striking the back wall with the most intensity directly in line with the slit. The line of brightness on the back screen shows that intensity. This is similar to the line the marbles make. But when we add the second slit, something different happens. If the top of one wave meets the bottom of another wave, they cancel each other out. So now there is an interference pattern on the back wall. Places where the two tops meet are the highest intensity, the bright lines, and where they cancel, there is nothing. So, when we throw things, that is, matter, through two slits, we get this, two bands of hits. And with waves, we get an interference pattern of many bands.
The double slit experiment appears to be playing out also in the particles that I've been isolating from Manuka honey. They are able to form interference patterns with each other and with themselves depending on the number of monoatomic minerals that are bound to the phenolic compounds within the particles.
Good so far. Now, let's go quantum. An electron is a tiny, tiny bit of matter, like a tiny marble. Let's fire a stream through one slit. It behaves just like the marble, a single band. So, if we shoot these tiny bits through two slits, we should get, like the marbles, two bands. What? An interference pattern. We fired electrons, tiny bits of matter through. But we get a pattern like waves, not like little marbles. How? How could pieces of matter create an interference pattern like a wave? It doesn't make sense.
So the inability to make sense of the waves that are present within this quantum realm means that when I observed what we're seeing on the screen now, which is a reaction between compounds within Manuka honey, methyl glyoxal bound to iron reacting with hydrogen peroxide in the presence of a phenolic called phenolactic acid, I was seeing things that I didn't know how to make sense of. So I had to really go back to the drawing board. So what's happening here is light is being captured and then light is being emitted as a photon. And you can see the bubble grows, and out of the bubble there's kind of two sides like yin and yang, and from the center of that comes a photon of light. So each jump that occurs is actually responsible for capturing light and transferring that energy into the aromatic ring and onto the monoatomic mineral that's present. So this is another reaction, except there's lots of them happening all at once, and you can see how bizarre they are. They're just popping up all over the place. They jump from one place to another, and it's the emission of that light being captured by another aromatic ring in another structure. So it's happening so quickly that the eyes can't see. The complexes that are present within Manuka honey are doing this very, very fast chemistry called photophenton chemistry. It's all being driven by light. So in a sense, it is quantum in its reactivity, and that quantum state provides a connection. The connection allows the material to be able to work together, because that quantum entanglement, that communication that occurs across distance, is really what holds everything together and making it work as one. So when I'm swapping between one wavelength of light and then another, I can get the formation of a structure, and then I go back to bright field.
But physicists are clever. They thought maybe those little balls are bouncing off each other and creating that pattern. So they decide to shoot electrons through one at a time. There is no way they could interfere with each other. But after an hour of this, the same interference pattern is seen to emerge. The conclusion is inescapable. The single electron leaves as a particle, becomes a wave of potentials, goes through both slits, and interferes with itself to hit the wall like a particle. But mathematically, it's even stranger. It goes through both slits, and it goes through neither. And it goes through just one, and it goes through just the other. All of these possibilities are in superposition with each other. But physicists were completely baffled by this. So they decided to peek and see which slit it actually goes through. They put a measuring device by one slit to see which one it went through and let it fly. But the quantum world is far more mysterious than they could have imagined. When they observed, the electron went back to behaving like a little marble. It produced a pattern of two bands, not an interference pattern of many. The very act of measuring or observing which slit it went through meant it only went through one, not both. The electron decided to act differently, as though it was aware it was being watched. And it was here that physicists stepped forever into the strange, never world of quantum events. What is matter? Marbles or waves? And waves of what? And what does an observer have to do with any of this? The observer collapsed the wave function simply by observing.
So the act of observing is an interesting phenomenon, because we are the conscious observers of our own subconscious mind physics. That's my hypothesis, that we are looking within because the human retina are actually anatomically pointed inwards. We see our dreams at night when we sleep with our eyes closed. So the only way we can see that light is if that light is generated within us. and the photoelectric effect corresponds to wavelengths of light that are visible in the Balmer line transitions for hydrogen. So I've really just put the pieces of the puzzle together logically without using measurement, and considering the experience that I had provided me with a different understanding of how our vision system works and where the original point of vision comes from, in that electron transition jumping from one orbital into another orbital, and as the electrons come back down they release photons of light. So that released photon is able to be observed by the human retina, and that is where our vision comes from, and that's why there's a delay in conscious reality from actual reality. So one of the first, I guess, parts of my model, which came really in a flash of brilliance, was understanding the concept of oneness, unity, and seeing everything as one. That's quite difficult considering the complexities of the universe around us that we currently observe. So how do we get to that point of being able to understand the point of oneness? It came from a number of observations. One, that the current model that science uses has some holes in it. Big gaping holes. One, in physics, is the inability to connect quantum physics with Newtonian physics. The inability to create a nice simple model to really incorporate gravity into the quantum physics, Schrodinger's equations. So, I'm no mathematician, so I used intuition, hindsight, foresight, and I believe that really we've already done this previously, and it's written in some very, very archaic texts that provide us some kind of different perspectives on where materialistic science currently holds its viewpoint. So I decided to look again at the model that we're currently using, the concepts that everything arose from nothing. It didn't sit well with me at all. Whereas, energy comes from something, cannot be destroyed nor created. So from that perspective, everything must have been present prior to the Big Bang, or the concept of the Big Bang. So if everything was present prior to the Big Bang, then what did it look like, and why can't we see it? So from that perspective, I made a conscious decision that it must have been one thing. And from that perspective of oneness, without contrast, because our eyes can only see contrast, so we're unable to observe what was there prior because there is no contrast within that system itself. So if it was all in a symmetry state, what is the one material in the universe that we know about that has symmetry within it? Plus there are some other concepts that religion has, the Father or God as well as some of the other Eastern philosophies about the liquid waters of the universe. So I brought those kind of concepts together. Einstein was a really smart man and decided that, well, possibly could it be a Bose-Einstein condensate where everything was helium? And the structure of helium and its geometry as a quantum superfluid. And that was really kind of bringing together the concepts of God the Father, or He. The masculine is coming from the name helium, or the symbol He. The attributes of the liquid waters of the universe being a quantum superfluid. Yeah, well, helium is a liquid when it's super cool. So, those two kind of pieces of the puzzle would say, well, yeah, that could be realistic. Bose-Einstein condensate is a quantum superfluid. It has some really weird properties. Okay, so let's start from that point. That the point of oneness is a Bose-Einstein condensate of helium. Okay, so what do we then consider? So the Bose-Einstein condensate, with its magical properties of quantum entanglement and supersymmetry, allow it to get to a point where it is in perfect symmetry, the symmetry of a cross. And from that symmetrical state, there is something that magical. What is magical is every action has an equal and opposite reaction. So the point being is that there's a laziness within quantum physics, and the laziness is prior to measurement. So before measuring anything, it can be anything and everything, right? It's only after measurement that the state is actually determined. So being a conscious observer, if we decide not to measure, then we get to at least play the mind game of what does it look like prior to measurement. And it's from that perspective, well, it was actually in harmony, in supersymmetry, but not only in a symmetry state of a cross, but a symmetry state of inversion, where every action has an equal and opposite reaction. So there was that playing in the background, as well as the concept of oneness, of unity, and the concept of, well, let's look at the numbers in the current scientific model, physics model, for electrons, protons, and neutrons. Hi, everybody. My name's Dr. Kieran Johnson. I'm a quantum biologist, and I just want to give you some information regarding quantum biology, how to integrate quantum physics into biology. Not an easy thing to do. So what we're going to do today is start with some basics. Okay. So I'm going to give you the standard model of physics that biologists are concerned about. In biology, we're only really concerned about electrons, protons, and neutrons. So let's start with defining the standard model of an electron, proton, and a neutron. And then we'll look at the new quantum physics-based approach to do this. Okay, so standard model in physics, an electron. Okay, the electron has a charge of -1. Okay, and an undefined size. But it has a defined mass. Okay, and that's very small. Now the proton has a mass of 1 and a charge of +1. The neutron, the mass of 1 and a charge equaling 0. Okay, so they are the 3 basic building blocks of biology based on the standard model of physics. So the electron has a charge of -1 and has a very small mass. The proton is made of 3 quarks, 2 up, 1 down, and it's given a charge of +1. Current scientific model suggests that the quarks pointing up are 2/3 and the quark pointing down is -1/3. So that's the assignment based on adding the quarks together. The neutron, 0 charge, but the quarks are 2 down, 1 up. And so again added those -1/3, -1/3, and 2/3 together to get 0. So that is the current standard model of physics that is being used, which I believe is incorrect. So I thought about it and I went, okay, what if I multiply and I make my quark pointing up -1 and my quark pointed down +1? So if I do that, then I get -1 times 1 times -1 is +1. So I've got +1 for my proton as a charge. So that makes sense. But then my neutron is 1 times -1 times 1, which is -1. So I have a -1 neutron. So how can I get 0 charge on my -1 neutron if I have, I have the wrong charge, right? So you would dismiss the model outright and go, no, that's very, very incorrect compared to what we're observing of +1 on a proton, 0 on a neutron. However, if you actually look at the masses of an electron and the masses of a proton and a neutron, so protons and neutrons are interchangeable through beta plus, beta minus radioactive decay. There's also something known as K plus or electron capture. So the interchange of protons and neutrons and the emission of positrons means that actually the mass of a neutron, which is larger than the mass of a proton, could be accounted for by the presence of a positron or the antiparticle to the electron within the actual model itself. So the added mass of the neutron that is present within an atom is actually accounted for by the addition of an additional electron and the inside surface properties of that electron being positive charge, giving us the positron. So I changed the concepts of adding to multiplication, and all of a sudden I started to get a different model that made sense. A model where there is a symmetry of plus and minus that is inbuilt into the structure of an atom itself. And from that geometry of opposites, I started to see something very, very interesting. Hey, back again. So the non-standard model of physics can be a little bit tricky for people who know science. and have been taught that there's a one way of looking at things. So I'm going to give you an opposing view, and that may or may not resonate with you. You may consider that as you may consider it as strange, but let's progress and actually have a look at an alternative viewpoint. Okay, so we divide in half. On this side, we have the standard model, and on this side, a new interpretation. Okay, so standard model, the electron, -1 charge, a proton, +1, a neutron, 0. Okay. The new interpretation is that an electron is -1, a proton is +1, a neutron is -1, and a positron is +1. Now, how do I go from the standard model to the new interpretation? It's a very good question. Okay, so we have in the proton and in the neutron 3 quarks. Okay, so quarks, and we're talking about up, down, up for the proton, and in the neutron, down, up, down. Now, in my new interpretation, in my new model, I still have up, down, up as the proton, down, up, down as the neutron. Okay, in here we have, in the standard model, we have, if it's up equals 2/3, down equals a -1/3. This is for charge calculations, where up plus down plus up equals 1, down plus up plus down equals 0. Okay, so they're the charges based on these calculations of adding. The new interpretation is up equals -1, and down equals +1. And in this case, it's multiplication. Okay, so -1 times 1 times -1 equals +1. +1 times -1 times +1 equals -1. Okay, so our proton in this new model is still +1, but the neutron is -1. The charge balance for the neutron comes from the inclusion of this positron, where -1 plus +1 equals 0. Therefore, the overall charge is 0 on a neutron, and the positron is included into the model to give symmetry. So there is a symmetry here and a symmetry here. So this is a lambda wavelength between the positron and the electron. So this is a photon. So now we're building in light within the structure of an atom. And as you can see, up, down, down, up, down. There's a distance between these. Halfway between the distance, again, there are balance of opposites. A symmetry inversion within the atom, within the proton and the neutron, to give symmetry and balance and stability. So, helium is considered to have 2 protons, 2 neutrons, 2 electrons. If we then add the 2 positrons for every 2 neutrons that are present in helium, all of a sudden you get a different model. Okay, so you have a cross-base symmetry within helium itself. As a Bose-Einstein condensate, that geometry starts to look very, very interesting. So in lesson 2, I'll be discussing the Bose-Einstein condensate geometry in relation to Einstein's equation E equals mc squared, and proposing the origin of the universe and the generation of dark energy, dark matter, and virtual particles. Hope you enjoyed the first lesson. Thank you.